Hello friends, welcome to another lesson in our Dart and Flutter course. Today we will dive into a very important topic, List View. This is one of the key widgets you will need to create long lists in your app. We will discuss its structure, capabilities, and figure out how it works. Let's start with the basics. List View is a widget used to create lists in an app. In real life, it's like a newsfeed on social media or a contact list on your phone. When there are many items, we want them to be scrollable. This is where List View comes into play. List View allows you to display multiple items on one screen and manage scrolling, even if there are more items than can fit on the screen at once. Now, let's take a look at the main types of List View provided by Flutter. List View itself is a widget. It initially inherits from Box Scroll View, which in turn inherits from Scroll View, and Scroll View inherits from Stateless Widget. But besides the basic constructor, List View also has named constructors such as Builder, Separated, and Custom. Let's start with the simple constructor. In this case, we have a list view with 3 tall containers. It's very similar to column, but it allows us to scroll if the items don't fit on the screen. Here's how it looks. Now, let's talk about the next constructor, which is the builder. With it, we can create lists with an unknown number of items in advance. It has parameters such as item builder, item count, and so on. Let's start with the item builder parameter. It takes a function with parameters build context and an int, which represents the index. In this function, we need to return an object of type widget. I'll explain the logic. Each item that needs to be drawn in the list will go through this function. So when Flutter needs to render the first item, this function is called with the context and an index of 0 since indexing starts at 0. The next item will be drawn in the same way, but the index will be 1. The widget we return will be displayed in the list. Since we have control over the index, we can create beautiful lists where items can differ from each other. For example, let's return a container with a certain height. Now, let's give our container a color, but one that will depend on the index and thus on the item number. How can we do this? It's simple. The color class has a named parameter called FromRGB, which allows us to specify a color in the following format. First, we specify the alpha value, which controls transparency. Then the red, green, and blue values. All these values are specified as numbers between 0 and 255. We can do the following. In this function, we'll create int variables for each color. As their value, we'll multiply the index, which is unique for each item, by any number, say 77. But now, it might happen that this number will be greater than 255. Which is not suitable for us. So, recalling our lesson on operators, we can use the modulus operator to get the remainder of division. And we'll take the remainder of division by 256. You might ask why 256 and not 255? The reason is that if the number we get from multiplication is less than or equal to 255, dividing it by 256 will give us 0, and the remainder will be our number. So in the end, if our variable is less than 256, it will stay the same. And if we get a number greater than 255, which doesn't work for the function, the remainder of the division will reduce it. This way, we'll get a nearly unique number for each item, and it will be less than 256. This might seem very confusing now, but don't worry. After some practice, you'll easily understand this syntax. Let's multiply each color by different numbers, say 88 and 99. So now we have 3 variables that are different for each item because the index is used in the expression. Now, we'll pass these variables to the constructor for the color. Note that the first parameter for all items will be 255, meaning the maximum value. This is to make our items fully opaque. Then we pass our variables that represent the colors in order. The next parameter we need to pass is item count. This controls how many items will be in our list, and therefore how many times the function we pass to item builder will be called. Let's use randomness to make this number random. In Dart, there's a class called random. By default, it's not imported, so we can do this with the help of IDE suggestions. This class has a method called nextInt, which takes one integer parameter. With this parameter, we specify the maximum number for the randomizer. Let's set it to 100. This way, we'll get a random number between 0 and 100 each time. Let's run our app. We see colorful containers that we can scroll through. Each time we restart the app, the number of items will be different due to the randomizer. But notice that the colors will always be the same because they depend on the index, not the randomizer. Now, let's try wrapping our list view in a column. Doing this, we'll see a white screen and an error. But what's the issue? By default, list view and other scrollable widgets occupy all the available space along the scroll axis. For example, if you use list view in a container with a fixed height, by default, list view will try to occupy all that height, even if there are only a few items. If we use list view in a scaffold, as we did now, it will occupy the entire height of the screen. But widgets like column don't have a fixed height, which causes the error. To fix this, we can wrap our list view in expanded, which we covered in the last lesson. This way, list view will try to occupy the entire available height within the column. Another option is to use the shrink wrap parameter. The shrink wrap parameter is used to control how list view handles its size. Specifically, shrink wrap dictates whether the list should occupy all available space or shrink to the minimum size needed to display all items. But first, we need to perform a few manipulations. First, we will wrap our column in a widget called Single Child Scroll View. This widget allows scrolling of its child widget if its size exceeds the available space. If we set the shrink wrap parameter to true, the list view will no longer occupy all the available space along the scroll axis. Instead, it will shrink and use only as much space as needed to accommodate all its items. In other words, if there are only a few items, the list view will not reserve extra space. Additionally, we need to set the primary parameter in list view to false. As the name suggests, this parameter determines whether the list view is the primary scrolling widget in your app. Since we wrapped our column in Single Child Scroll View, we want the primary scrolling widget to be Single Child Scroll View rather than list view. So we set primary to false, and our code is working now. If we didn't use Single Child Scroll View, our list view would be displayed, but it wouldn't scroll. Try to replicate this yourself. Now, let's look at list view separated. This type is used when you need to add separators between list items. It's almost the same as ListView.builder, but it has one mandatory parameter called separator.builder. It has the same type as item.builder, which is a function that returns a widget and has context and index as parameters. In this function, we need to return a separator between the items in the form of a widget. For example, let's return a brown container with a small height. Running the code, we see that a container appears between each of our items, acting as a separator. We can remove the color, and it will become something like padding. By the way, it's important to know that ListView.builder only creates the items that are visible on the screen. Under the hood, it works like this. When an item is scrolled out of view, Flutter destroys it, freeing up memory. If the item reappears on the screen, Flutter recreates it. This mechanism is called lazy loading. It's crucial for app performance because without this mechanism, lists with many items would significantly slow down the app. Today, we have thoroughly explored the basic aspects of list view in Flutter. We learned how to use basic lists, dynamically create items with ListView.builder, and add separators with ListView.separated. This topic can be quite challenging, so don't worry if a lot of it seems unclear. Just keep watching the lessons, and when we start writing practical applications, everything will become clear to you. Thank you for watching this video. If you found it helpful, give it a like, subscribe to the channel, and don't forget to enable notifications so you don't miss new lessons.